Today we're going to be talking about graphing exponential and logarithmic functions. First, we're going to start by completing the table for each exponential function. So y is equal to 2 to the x power. Let's go ahead and plug in a -2, see what we get out. Plug in -1, see what we get out. 0, 1, and 2. Remember our negative exponents, 2 to the -2 power, we write it as a ratio, so it is actually 1 over 2 squared. Go ahead and write that. So 2 to the -2 power is the same as 1 over 2 to the second power, and that would be 1 over 4. So don't forget about the rules of negative exponents. Okay, so we're going to start number 2. F of x is equal to 3 to the x power. Plug in -2, -1, 0, 1, and 2. This would be our domain. Let's do the last one. You go ahead and try it, and then when you're ready, see if you got it correct. All right, here we go. Did you get those answers? Okay. Did you get those answers? Hopefully you did. So what we're going to do now is we're going to sketch the graph of the exponential function, 2 to the x power and its inverse. We carried over the graph that we had from the previous slide. So we're going to go ahead and graph these points. -2 and 1/4. -1 and 1/2. 0, 1. 1, 2. And 2, 4. Okay? So we get this exponential curve right here. And now what we're going to do is we're going to graph the inverse. What do we do when we graph the inverse? Yes, we switch the x's and the y's. So here we had -2 and 1/4. So we switch it and we have 1/4 -2. That's how we do the inverse. So we're going to go ahead and graph those points. Take a look at it. Anytime you have an inverse, it's always reflected along this line that goes through the origin at a 45-degree angle. This is called the y equals x line. So this is our exponential function. Take a look. This is how you want your money to grow when you get great jobs and you start to invest in your retirement. You want it to grow exponentially. So this is your exponential function. Over here, the inverse of exponential is logarithmic. And here's your logarithmic function. Okay, comes up, crosses the x-axis, and sort of tapers off, but it still goes up at a slow rate. So let's talk about how to write that as a log, because a log is going to be the inverse of your exponents. So we write that as y is equal to log base 2 of x. Log base 2 of x. You always have this subscript right here, 2, and it always matches your base here. So log base 2 matches the base up here. Okay, so y-intercept, we let x equal 0. So here you can see when x is 0, y is 1, and you can also see it going through the graph at that point. Logarithmic, look at that, the inverse, 1, 0. Here it is, 1, 0. This is going to have a horizontal asymptote at y equals 0. Horizontal line goes across. Horizontal line again, our boundary line. So here's y equals 0. Notice how that red graph, exponential graph, does not go below y equals 0. Horizontal asymptote. Let's take a look at our logarithmic function. It has a vertical asymptote. Here it is right here. This is a line that graph will not pass, or cross, or touch. So our logarithmic functions have a vertical asymptote and our exponential functions have a horizontal asymptote. All right, so now we're going to take what we learned about transformations, you know, left and right and up and down. Let's see if we can graph this. The steps are at the bottom. We're going to first make a table of the parent function, which is just 3 to the x power. Here are our x's. We plug them in. Here are our y's. For exponential functions, we're going to graph at least 5 points from the table and we're going to connect it with a dashed line. That'll be our parent function. And here we go. -2 1/9, very close to the origin. negative 1 1/3. Not as close. Going up a little bit. 0, 1, 1, 3, 2, 9. There we go. There's our dashed line. We're not using logarithmic in this case. We're just graphing the function that we're given. So we are going to translate each point 4 units down. 4 units down. Okay. So I take this point and I go down 4, 4, 4, 4, and 4. This was my asymptote initially. It was at y equals 0. So what do you think we're going to do with that? You guessed it. We're going to take it down 4 units as well. Let's go ahead and connect the translated dots, points with a solid line, and here is our new graph. Here's our initial graph, and this is our transformed or translated graph. Let's try a couple. This is y equals 3x, 3 to the x power plus 3. Here is our horizontal asymptote. Why is it up here? Well, because we had to actually move it up. We grab those points, moving each point up by 3, and voila, here's our new graph. Take a look at number 3 before you get to graphing. What do you notice that's different? Well, next to the x, I have x minus 2. So there's going to be some type of shift right or left. And here we have minus 4 outside of the exponent. So it's going to do something. It's either going to go up or down. What do you think? Hopefully you said down. Here's the parent function already graphed for you here. What are we going to do? Go ahead and put in place our horizontal asymptote. We're going to shift every point over 2 and down 4. Every point over 2 and down 4. And then we're going to connect it. And there we have it. Our new graph. Now logarithms. Logarithms may be new to you. There is a button on the calculator which you'll be shown how to use at a later time. However, we know it's the inverse of exponents. So this is what we're going to do. We're going to make a table for an exponential function. Y equals 3 to the x. Why are we using 3? Because that is your base. And so it is your base for your exponent. So we're going to go ahead and plug in our values for the domain. And this is what we get out for the range. Now, what we're going to do, since this is a log, we're going to actually graph or put the points of the inverse in a table. So we switched all our x's and y's. That's what we did. We are going to go ahead and graph those points. 1/9, barely going over and then going down 2. 1/3, down 1. 1, 0, 3, 1, and 9, 2. We are going to connect those. So now this says that it shifts over 2 units. Which way does it shift over 2 units? You got it. It shifts to the right. We shift every point over 2 units. And we go ahead and put in our vertical asymptote. This was the line that our logarithmic function did not cross. However, if we're going to move over 2, guess what we have to do with that asymptote? Move it over 2 as well. I'm going to go ahead and connect those points for a solid line. And here is our new graph of the function log base 3 of the quantity x minus 2. All right, here are 2 additional graphs. Let's talk through this. Here we see is log base 3, and then in parentheses we have x plus 4. What's the expectation here? Is it to go to the right, the left, up, or down? Because it's in parentheses, this is going to go to the left 4 units. Let's go ahead and start out with our parent function of a log. We know it's shifted over 4, so we're going to take our vertical asymptote and shift it over 4. We take all of our points and we move them back 4. So here, 1, 2, 3, 4. Every point goes back 4. And once we have that in place, we connect it. We'll do this last one. Transformation. It goes to the left 4. It also goes down 2. Let's go ahead and move our vertical asymptote. It is normally right here at x equals 0. However, we're going to move it over 4. This is the new location. Every point is going to go to the left 4 and down 2. Every point. Excuse me, not down 2, up 2. Here we go. Once we get it in place, we connect it. Folks, those are your graphs of logs and the exponents. Let's take a look at what a logarithm is. A logarithm is just a special way to ask a specific question. The question is, b raised to what power is a? B raised to what power is a? Logarithms, inverse, exponents. So if we're going to write it in exponential form, b raised to what power is a? B raised to what power is a? This is how we will put it in exponential form. And if we kept it in log form, log base b of a is equal to x. So, oh no, my logarithm has no base. Notice we have log base b to the b raised to the x power. When you see that your base and your value right next to the base are the same, you're going to notice that you're just going to get x. Same here, if we exponentiate and take b and raise it to the log base b of a, those are also going to cancel out. So what are we saying? If you don't have a base here, it is 10. You can go ahead and say it's 10. So log of x is the same as saying log base 10 of x. You may not see this much, but natural log, or ln(x), if you see it like that, is going to be the log base e to the x. You may see that in more of your science classes, but we definitely introduce it here. All right, what we're going to do now, we're going to take exponential and we're going to convert it to logarithmic. Exponential to logarithmic. If you have trouble with this, see your teacher, rewind, and try it again. So 2 to the third power is equal to 8. We want it in logarithmic. 2 to the third power is equal to 8. So since the base is 2, we're going to write log 2 on each side. We know that if this base and this number are the same, this power here will come down and it'll just be 3 left in the problem. So now what do we have? 3 is equal to log base 2 of 8. What did we just do? We converted from exponential to logarithmic. Number 2, we're going to go from exponential to logarithmic. 4 to the second power is equal to 16. Since the base is 4, we're going to introduce log 4 on each side. What happens if we have a base and it is log base 4 to 4? You got it. It's going to cancel out and we get 2 log base 4 of 16. What did we just do? We converted exponential to logarithmic. All right, now let's go from logarithmic to exponential. Here we know the base is 3. We're trying to get rid of the word log and end up with the word exponent. So 3, we're going to exponentiate. That means raise it to the power. So 3 raised to the power log 3 of 81 equals 3 raised to the 4th power. Well, you notice that in the previous slide, in your previous notes, that if you have your base and your log base the same, they cancel out. So what we have over here is 81. So 81 is equal to 3 to the 4th. Well, guess what? In this case right here, we don't have log anymore. So were we successful going from logarithmic to exponential? Yes, we were. This one, log base 2 of 1 over 8 equals -3. The base is 2, so we're going to exponentiate 2 raised to this power and 2 raised to this power. What happens when we raise something to a power and the bases are the same? Cancel out. We now have 1/8 is equal to 2 to the -3 power. All of this can be verified using your calculator, but we definitely show you how to do a lot of the math by hand. Thank you for tuning in.